My name is Amador Ponce. I am from UAT-UAMRA, and I'm going studying petrochemical process engineering. And I'm going to talk about ethylene, uses of the ethylene, and the complex that produce it.
Ethylene. Ethylene is an hydrocarbon which has the formula C2H4 or H2C equals CH2. It is a colorless flammable gas with a faint, sweet and musky odor when pure. It is the simplest alkene, hydrocarbon with carbon-carbon double bonds. Ethylene is widely used in the chemical industry and is worldwide production except that of any organic compound. Much of this production goes toward polyethylene, a widely used plastic containing polymer chains of ethylene units in various chain lengths. Ethylene is also an important natural process. Plant ethylene is produced by several methods in agriculture to form the ripening of fruits. Ethylene, a primary method, is steam cracking, where hydrocarbons and steam are heated to 750 ethylene to 915 degrees. 1. This process converts large hydrocarbons into smaller ones and halogenation and hydrohalogenation. When ethene is the alkylation, ethylene is the product. Hydration is separated from the resulting mixture oligomerization by repeated compression and hydroformylation. Other technologies employed for the production process. Of ethylene include ethylene is produced by several methods in the petrochemical industry. Synthesis, a primary method is steam cracking, catalytic, where hydrocarbons and steam are heated laboratory 715 to 900 value industrially. This process converts large hydrocarbons in the smaller ones laboratory and is ordinarily purchased. It can be produced via the hydration of ethanol with sulfuric acid. Ethylene is separated from the resulting mixture with aluminum by repeated compression and distillation. Other technologies employed for the production of ethylene include oxidative coupling of methane, Fischer-Tropsch synthesis, and methanol to olefin and catalytic dehydrogenation. Laboratory synthesis. Although of great value industrially, ethylene is rarely synthesized in the laboratory and is ordinarily purchased. It can be produced via the hydration of ethanol with sulfuric acid or in the gas phase with aluminum oxide. Polyethylene. Polyethylene or polyethylene is the most common plastic. Its primary use in packaging, plastic bags, plastic films, geomembranes, containers, including bottles, etc. Many kinds of polyethylene are known, with most having the chemical formula polyethylene is defined by a density of greater equal. Polyethylene is usually a mixture of similar polymers of ethylene with various values of N. Polyethylene is a thermoplastic, however, of range. It can become a thermoset molecules when modified well, such as intermolecular forces are stronger than in highly branched polymers. Low-density polyethylene is defined by a density range by chromium, silicia, 9 catalyst, 110 similar nata, 0.9 catalyst, or metallocene catalyst. By choosing catalyst and low-density polyethylene has a high amount of breaking that and alone can be controlled. This means that the chains do not prefer the formation of free radicals at the ends of the growing polyethylene. Less strong intermolecular force as the new ethylene monomers to add to the end dipole of the molecule is less, rather than along the middle lower causing the growth of a linear chain and increased ductility. High-density polyethylene has high-density strength by free radical polymerization and packaging. The high degree of breaking with long detergent bottles, butter tubes, low-density polyethylene, unique and desirable flow properties. Low-density polyethylene is used for both rigid container and plastic film applications such as plastic bags and film wrap. High-density polyethylene. High-density polyethylene is defined by a density of greater or equal to 0.941 grams for cc. High-density polyethylene has a low degree of breaking. The mostly linear molecules pack together well, so intermolecular forces are stronger than in highly branched polymers. High-density polyethylene can be produced by chromium silica catalyst, Ziegler-Natta catalyst, or metallocene catalyst by choosing catalyst and reaction conditions. The small amount of breaking that does occur can be controlled. These catalysts prefer the formation of free radicals at the ends of the growing polyethylene molecules. They cause new ethylene monomers to add to the end of the molecules, rather than along the middle, causing the growth of a linear chain. High-density polyethylene has high tensile strength. It is used in products and packaging such as milk jugs, detergent bottles, water tubes, garbage containers, and vapor pipes. Properties. Mechanical properties. Polyethylene is of low strength, hardness, and rigidity, but has a high ductility and impact strength as well as low friction. It shows a strong creep under persistent force, which can be reduced by addition of short fibers. It feels waxy when touched. Thermal properties. The commercial applicability of polyethylene is limited by its comparable low melting point. For common commercial grades of medium and high density polyethylene, the melting point is typical in the range of 120 to 118 degrees. The melting point for average commercial low density polyethylene is typically 105 to 115 degrees. These temperatures vary strongly with the type of polyethylene. Chemical properties. Polyethylene consists of non-polar, saturated, high molecular weight hydrocarbons. Therefore, its chemical behavior is similar to paraffin. The individual macromolecules are not covalent linked. Because of their symmetric molecular structure, they tend to crystallize. Overall, polyethylene is partially crystalline. Higher crystalline, increased density, and mechanical and chemical stability. Most low-density polyethylene, middle-density polyethylene, and high-density polyethylene grades have excellent chemical resistance, meaning they are not attacked by a strong acid or strong bases, and are resistant to gently oxidant and introducing agents. Crystalline samples do not dissolve at room temperature. Polyethylene, other than cross-linked polyethylene, usually can be dissolved at elevated temperature in aromatic hydrocarbons such as toluene or xylene, or in chlorinated solvents such as trichloroethylene or trichlorobenzene. Polyethylene absorbs almost no water. The gas and water vapor permeability, only polar gases, is lower than for most plastic, oxygen, carbon dioxide, and flavorings. On the other hand, can pass it easily. Polyethylene can become brittle when exposed to sunlight. Carbon black is usually used as stabilizer. Polyethylene burns slowly with a blue flame having a yellow tip and gives off an odor of paraffin, similar to candle flame. The material continues burning on removal of the flame source and produces drip. Polyethylene cannot be impregnated or bound with adhesives without predetermined high-strength joints are readily achieved with plastic welding. Electrical properties. Polyethylene is a good electrical insulator. It offers good electrical threading resistance. However, it becomes easily electrostatically charged, which can be reduced by addition of graphene, carbon black, or anti-static agents. Optical properties. Depending on the thermal history and film thickness, polyethylene can vary between almost clear, transparent, milky opaque, translucent, or opaque. Low density polyethylene, the Revi owns the grades. Low density polyethylene, slightly less, and high density polyethylene, the less transparent. Transparency is reduced by crystallities if they are larger than the wavelength of visibility light.